First thing I want you to remember is that I've mentioned this the other day. Sine squared x or sine raised to the exponent 4x you might be wondering, okay, what on earth is sine squared? Is that sine squared times x? Sine of what squared times x? Let me write some common misconceptions. Okay, so incorrect. So sine squared x equals sine squared times x. That's just not true. Okay? Or is equal to x sine squared. That doesn't make sense. You have to have sine of an angle. So that can't be true. Okay? Actually, that's the only misconception that I can think of right now. But what it really is sine squared x is equal to sine x squared, which might seem kind of weird. And by that same logic, sine to the exponent 4x is going to be sine x raised to the exponent 4. I could even see this as I can even do this, because we're actually going to see this in this example. Oh my goodness. Okay, that's this. Okay. So when you're looking at this, you're going to ask yourself, okay, well, which one of these is more challenging? The left side or the right side, which one you want to deal with first? And to be honest, these seem kind of equally challenging. In fact, yeah, equally challenging. So it doesn't really matter which one you pick if they both look challenging, but I'm just going to go with the left side because I think the only reason why I'm picking the left side is because, look, I've got a cos here and a tan here, whereas over here I've got all sines. So eventually, look, the whole idea here is that you're going to transform this left side using trigonometric algebra and manipulation to make this look like this. So left side equals this. First of all, you're going to apply what you already know, so basic trig ratios. I know that, let me just rewrite this in this form so that it might be nicer to look at. One minus. You don't have to do this step if you're okay with looking at it like that. Okay? So that's all this is. You know what tan x is? What's tan x? Anyone? Well, tan x is sine x over cos x, right? Aside, tan x equals sine x over cos x. So this is the whole idea of applying simple identities, this quotient identity, into other identities. Okay? Let's do that. 1 minus cos x squared, 1 minus sine x over cos x. Okay, we're far from getting there. We still have a cos x here and a cos x there, but eventually we want them all to be sine x's. Okay? 1 minus cos squared x. Do we have an identity over here? And this does take a lot of practice. But if you recall the Pythagorean identity, can anybody recall the Pythagorean identity?
Sine squared beta plus cos squared theta is equal to 1.
Yeah. Sine squared x, or theta. X represents the angle in this case. So, what do we have here? Sine squared x equals 1 minus cos squared x. And look, here's a 1 minus cos squared x. Now we can get rid of this. This whole thing is 1 minus cos squared x. So I'm going to write that right here. This is actually sine squared x, or sine x squared. Right? That times 1 minus sine x over cos x.
Mr. Lee, shouldn't there be a squared on the sine x over cos x?
Yes. Right here. Thank you. So therefore, we're going to square this bottom. We're going to do that, okay? Let's do this. Okay. Next, what can we do? Let's just expand. So we got, I'm going to write this square inside now. And just so that you're familiar with that. So sine squared x times this times this. What are you going to do to the exponents? You're going to add them, right? All over cos squared x. Now, how far off are we from proving the right side? Look, we've actually done the top. And the bottom, cos squared x, we can apply the Pythagorean identity once more, cos squared x. So if I isolate cos squared x, it's just going to be 1 minus sine squared x. So sine squared x minus all over 1 minus sine squared x. Okay, and this is our right side. Our right side equals this as well. Okay. It's like when you check your work, when you're solving for a point of intersection and then you substitute your x value back into it. Since left side equals right side, or you can just say therefore left side equals right side. Why don't we say that? Therefore left side equals right side. It's proven. Okay? Questions? Let's do another one.
Mr. Lee?
Yes.
Wait, you see how on the third last step there's a 1 minus sine squared over cosine squared? So
this,
what happened to the 1?
I expanded this. I distributed this. I did this times that, and then this times that.
Okay, I understand. Thank you.
Good question.